Hello students, today we will do exercise 3.3 of pair of linear equations in two variables. Here we will use substitution method to solve the pair of linear equations in two variables. Now here in question number first, solve the following pair of linear equations by this substitution method. Now I am doing second part of it, that was s minus t equal to 3 and s by 3 plus t by 2 equal to 6. Now first of all we will simplify the equation second, that was s upon 3 plus t by 2 equal to 6. Now here the LCM of 3 and 2 is 6. After taking LCM we are getting the equation second as 2s plus 3t upon 6 equal to 6. On multiplying both sides by 6 we will get it as 2s plus 3t equal to 36. Now our first step is, after finding, we will find the value of any one of the variable in terms of the other variable. Now you can take equation first or equation second, whichever is convenient to you. Now I am taking equation first to find the value of s in terms of t. Now from equation first, s will be equal to 3 plus t. Now that I have taken as equation third. Now in second step we will substitute the value of the variable which we have obtained. Now here we have obtained the value of s. We will substitute the value of s in equation second as we have obtained it from equation first. Now if we are getting the value of s from equation second, then we will substitute it in first. Here we have obtained the value of s from first, so we will substitute it in equation second. Now on substituting the value of s in equation second, the equation second will become 2 into s. S means 3 plus t. So this will be 2 into 3 plus t plus 3t equal to 36. Now that will give us 2 into 3 will be 6 and 2 into t will be 2t. So 6 plus 2t plus 3t equal to 36. Now the variable 2t plus 3t will be equal to 5t, and after solving this equation we will get value of t as 6. Now after getting the value of one variable, we will put the value of that variable in any one of the equations, first, second or third, whichever is convenient. Here the most convenient way is to put the value of the variable in equation third. So we will put the value of t, that is 6, in equation third. Our equation third was s equal to 3 plus t, and this will become s equal to 3 plus, and in place of t we will take 6, 3 plus 6. Now on putting the value of t in equation third, we will get s equal to 3 plus 6, and that is equal to 9. That means we are getting the value of s here is 9 and value of t is 6. Now come to the fourth part of question number first, that was 0.2x plus 0.3y equal to 1.3. This was our first equation. Now as we see here, in coefficient of x, in coefficient of y, or in constant term, there is one term after the decimal. Thus we can eliminate this decimal by multiplying the equation by 10. So on multiplying the equation first by 10, it will become 2x plus 3y equal to 13. Similarly, the equation number second is 0.4x plus 0.5y equal to 2.3, and this can also be multiplied by 10 in order to eliminate the decimal, and that will give us 4x plus 5y equal to 23. Now we will find the value of any one of the variable from equation first and second in terms of the other variable. Now here I am using equation first to find the value of variable x in terms of y. Now from equation first, the value of 2x will be equal to 13 minus 3y, and that will give us x equal to 13 minus 3y by 2. Now in our second step we will substitute this value of x in equation second, and that will give us 4 into 13 minus 3y upon 2 plus 5y equal to 23. Now this 2 will divide this 4 by 2, and that will give us 26 minus 6y plus 5y equal to 23. Now from this we are getting the value of y as 3. Now here I am getting minus y equal to minus 3. So on multiplying both sides by minus 1, we will get y as 3. Now we have obtained the value of y. Now in our third step or last step, we will substitute this value of y in any one of the three equations, that is first, second or third. Now it is most convenient to put the value of x in y in equation third. We will use equation third. Now on substituting the value of y in equation third, we will get x equal to 13 minus 3. Now in place of y, we will take the value of y, that was 3. So 13 minus 3 into 3 upon 2, and that is giving the value of y as 2, x as 2. That means the value of x is 2 and value of y is equal to 3 in this pair of linear equations. In fifth part, linear equation in two variables x and y are given to us. First equation is root 2x plus root 3y equal to 0, and second equation is root 3x minus root 8y equal to 0. Now we will get the value of variable x from equation first, and that is minus root 3y upon root 2, and this I have taken as equation third. Now on substituting the value of x from equation third in equation second, we are getting the value of y as 0. Now after getting the value of y, we will put it in equation third, and that will give us value of x equal to root 3 into 0 upon root 2, and that is also 0. That means the value of x is 0 and y is equal to 0. Now in sixth part of question number first, we will first of all solve both the equations by taking the LCM, as we have done in second part of the question, and then after simplifying these two equations, we can proceed as we have done in earlier questions. In question number 2, we have to solve the equation 2x plus 3y equal to 11 and 2x minus 4y equal to minus 24, and then we have to find the value of m from the equation y equal to mx plus 3. Now first of all, we will solve these two equations to get the value of x and y. Now first equation is 2x plus 3y equal to 11, and second equation is 2x minus 4y equal to minus 24. Now from equation first, we are getting value of x as 11 minus 3y upon 2. Now on substituting this value of x from equation third in equation second, we are getting the value of y as 5. Now on substituting the value of y in equation third, we will get the value of x, and that is minus 2. Now we have to find the value of m from the equation y equal to mx plus 3. Now we have already obtained the value of y, that was 5. In place of y we will take 5, and in place of x we will take minus 2. Now this will be 5 equal to m, x means minus 2 plus 3. Now this will give us 5 equal to m into minus 2 will be minus 2m plus 3, and that is giving us the value of m as minus 1. Thus the value of x is minus 2, value of y is 5, and value of m is minus 1. In question number third, now the first part is the difference between two numbers is 26 and one number is 3 times the other number. Find them. Here we have to find these two numbers. First of all, we will form the linear equation in two variables by using the given information. Now I am taking the larger number as x and a smaller number as y. Now here in the question, he is saying that difference between two numbers is 26. That means larger number minus a smaller number will be equal to 26. This is our equation first. Now in second equation, now here it is given that the one number is 3 times the other number. That means the larger number will be 3 times the smaller number. And larger number was x and smaller number s was y. So x will be equal to 3y. Now here the variable x is already expressed in terms of y. So there is no need to solve this. We will directly substitute the value of x from equation second in equation first. And on substitution, we are getting the value of y as 13. On putting this value of y in equation second, we are getting the value of x as 39. That means the two numbers are 39 and 13. In second part of question number 3, it is given that the larger of two supplementary angles exceed the smaller by 18 degree. Find them. Now here I am taking the larger angle as x and the smaller angle as y. Here it is given that these two angles are supplementary. That means their sum will be equal to 180. The x plus y is equal to 180. And next thing given to us that larger angle exceeds the smaller angle by 18. That means larger angle minus smaller angle equal to 18, and that is giving us x minus y equal to 18. Now we will solve it by substitution method. From equation second, we are getting value of x as y plus 18. Now on substituting the value of x from equation third in equation first, we will get the value of y, and then we will put the value of y in equation third to get the value of x, and that will give us the two angles. In question number 3, the coach of a cricket team buys 7 bats and 6 balls for rupees 3800. Later she buys 3 bats and 5 balls for rupees 1750. Find the cost of each bat and ball. Now here we will take cost of each bat be x and cost of each ball be y. Now that will give us two equations. Now if the cost of one bat is x, then cost of 7 bats will be 7x, and 6 balls will be, and cost of each ball is y, so cost of 6 balls will be 6y. He is saying that 7 bats and 6 balls cost rupees 3800, so that will give us 7x plus 6y equal to 3800. That will be our first equation. And second equation, cost of 3 bats and 5 balls is 1750. That means 3x plus 5y equal to 1750. Now that will, from these two equations, we can find the value of x and y. That means that will give us the value of x as the cost of each bat, and value of y will be cost of each ball. Now in fourth part of question number 3, the taxi charge in a city consists of a fixed charge together with a charge for the distance covered. For a distance of 10 km, the charge paid is rupees 105, and for a journey of 15 km, the charge paid is rupees 155. Now what is the fixed charge and the charge per kilometer? How much does a person has to pay for traveling a distance of 25 km? Now for this we will take we have to find fixed charge and the charge per kilometer. We will take the fixed charge be rupees x and charge per kilometer be rupees y. Now here it is given to us that the charge paid for a distance of 10 km is 105. That means the fixed charge was x plus charge per kilometer was rupees y, and he has traveled 10 km. That means for 10 km he has to pay rupees 10y, and that is equal to 105. This is our first equation. Now charge paid for distance of 15 km is given to as rupees 155. That means fixed charge was rupees x plus, now for each kilometer the charge was rupees y, so for 15 km he will have to pay rupees 15y. The x and the sum of these two charges is rupees 155. Now these are our two equations in variable x and y. Now we can solve these two equations by substitution method to get the value of x and y. We are getting the values of x as 5 and y as 10. After solving, you have to solve it yourself. Now after this, it is also asked to you that what will be the charge paid by him to travel 25 kilometer. Now charge paid to travel 25 kilometer will be called fixed charge plus charge paid for 25 kilometer. Now fixed charge was rupees 5 plus 25y to 25 and value of y was 10, and that will give us rupees 255. That means the fixed charge is rupees 5 and charge per kilometer is rupees 10, and the charge paid for 25 kilometer is rupees 255. Fifth part of question number 3 is a fraction becomes 9 upon 11 if 2 is added to both numerator and denominator. If 3 is added to both numerator and denominator, it becomes 5 upon 6. Find the fraction. Now as we have to find the fraction has two parts, numerator and denominator. So we will take the numerator as x and denominator of fraction as y. Then the fraction will be x upon y. Now in first case, he is saying that if 2 is added to both numerator and denominator, the fraction becomes 9 upon 11. That means if we add 2 to the numerator and 2 to the denominator, it becomes 9 upon 11. And this is giving us the equation as 11x minus 9y equal to minus 4. Now the case second is given to us that if 3 is added to both numerator and denominator, it becomes 5 by 6. That means if 3 is added to numerator and denominator both, it becomes 5 by 6. And this is giving us an equation as 6x minus 5y equal to minus 3. Now we can solve equation first and second by substitution method to find out the value of x and y. Now here I am getting the value of x as 7 and value of y as 9. So the fraction was x upon y, and that will be 7 upon 9. Now last question of the exercise, that is 5 years hence the age of Jacob will be 3 times that of his son. 5 years ago Jacob's age was 7 times that of his son. What are their present ages? Here let the present age of Jacob be x and the present age of Jacob's son be y. Now two conditions are given to us. In first condition, he is saying that 5 years hence the age of Jacob will be 3 times that of his son. Now 5 years hence means after 5 years. Now what will be the age of Jacob? His present age is x. So after 5 years the age of Jacob will be x plus 5. Similarly the present age of son is y. So after 5 years the age of son will be y plus 5. Now according to the question, it is given to us that age of Jacob is 3 times the age of son. And we will solve this equation to find our equation first, that is x minus 3y equal to 10. Now the second condition is given to us that 5 years ago Jacob's age was 7 times that of his son. Now 5 years ago age of Jacob will be x minus 5. His present age is x, so 5 years ago his age will be x minus 5. Similarly age of Jacob's son will be y minus 5. Now according to question, the age of Jacob was 7 times the age of son. That means x minus 5 equal to 7 into y minus 5, and that is giving us the equation as x minus 7y equal to minus 30. This we will take as equation second. Now we will find out the value of the x from equation first or second. Here I am using equation first to find the value of x, and that will be value of x will be 10 plus 3y. Now we will substitute the value of x in equation second to get the value of y, and we are getting the value of y as 10 Now put the value of y in equation third to get the value of x, and that is 40. That means the present age of Jacob was x. That means the present age of Jacob is 40 years, and present age of Jacob's son is 10 years. Thank you.